and colleagues. My name is Alexander Steven, and today I'm going to present my final task for Kalbe Nutritionals and Rakamins Academy's Data Scientist Internship program. And for today's presentations, the topic will be sales predictions and customer segmentations using ARIMA model and K-means clustering. Before we move on to the presentations, allow me to introduce myself. My name is Alexander Steven. I'm a final year student at National Yunlin University of Science and Technology in Taiwan. I'm currently studying information management studies for my bachelor's degree and have a really deep interest in business analytics, data analytics, science, and visualizations field. And I'm currently learning about machine learning, about Tableau, SQL, and Python. So for this task, we have a background story. So as a data scientist at Kalbe Nutritionals, I was tasked by inventory team and marketing team to do some forecasting and customer segmentations. By the inventory team, they asked me to predict the daily sales of all of the Kalbe Nutritionals product, to estimate the quantity that will be sold to ensure the team has sufficient stocks and inventory. And for the marketing team, I was asked to make clusters or customer segmentations based off several criteria to be used by the team to create a promotions and give a personalized recommendations, promotions, and sales treatments to the customers. So first, before we move on with the forecast and the customer segmentations, we conducted an exploratory data analysis using PostgreSQL. Using the Beaver. So we have 4 queries in total. The first query would be average customer age based on their marital status. So here we can see that we actually have 3 different marital status, with the first one being the person did not input their marital status, which either married or single. So in reality, we only take 2 values, which is married and single. So in this case, you can see the married average is 43.04 years. And for the single marital status, it's about 29.4 years old. And for our second query, it's about an average customer based on their gender. So here the number 0 represents female and number 1 represents male. So we can take a look in the results. The average female customer is 40 years old, 40.32, whilst for our male customer, it's about 39 years old. So the distance is not really that far for both genders, actually. And for the third and the fourth query, it's a little bit more complex. So for the third one, we want to find the store with the highest total quantity sold. Excuse me for the background noise. So for the third query, the highest quantity sold by the store is Linga by 2,777 total amount. And for our fourth query, the best selling product with the highest total revenue would be cheese stick, with a total amount of revenue reached 27,615,000 rupees. And that is our exploratory data analysis for the SQL part. Next, we're going to take a look at the data visualizations. First, we are going to take a look at our monthly total quantity. So basically, we can take a look at our total quantity of items for each month. We can see from the visualizations that the peak was in the month of March at 1,753 items, and the graph itself shows a downwards trajectory, slightly a little bit of fluctuations, but overall it looks like it's heading slightly downwards until the end of December, which also our lowest selling quantity at 1,409 items. Then we're going to take a look at our daily sum of daily revenue. So we can see that our revenue actually fluctuates greatly. So the peak or the highest revenue was on March, the same as the previous one, which is on March, around 976,500 rupees, sorry. And the lowest is on August, which is only 123,600 rupees. So next we're going to take a look at the product quantity. So the highest selling product in our companies right now is Thai tea, with the peak reaches 2,853, and the lowest selling product is actually our cashew product, which only peaks at 627. So we can see that trend right now. People would prefer to drink Thai tea more than eating cashews, I assume. And then our total amount of sales by store name. So we can see that Lingga and Sinar Harapan both actually surpasses other stores in Kalbe Nutritionals, with the highest total amount being held by Lingga at 25,294,100 rupees. And the second highest is Sinar Harapan at 21,882,600 rupees. And we can see the lowest actually, it doesn't have a really big difference for this Prestasi Utama until Buana Indah, which only have like about 2 million gaps, 1.5 million gaps for each stores, for the rest of the stores. And the lowest is our Buana Indah store, which only 10,629,900 rupees. Next, we are going to take a look at our forecasting for our inventory team. So we are going to use ARIMA model for this forecasting. First, we're going to conduct some data cleaning with our tables, with our data. First, for our customer table, we can see that on the left side, it has no value for its marital status. The total for this table actually has 3 no value for the marital status, so we decided to drop those non-value, and then we changed the income into following the US, the Western way of writing decimals, which is using dot or point instead of using comma. So here we changed the 5,12 into 5.12, and as well as changing the data type into floating. Then we also changed the latitude and longitude for the store data table. Here, the same as the previous table, we changed them from using comma into point, just like in the previous table. So we can see the cleaned version on the right hand side. And then for our product, I didn't do any other cleaning because the product itself is pretty clean in my opinion, so I didn't do any other cleaning for this data table. And for our transactions, we changed the date. So instead of using day, month, year, we changed them into following a date time. So it becomes year, month, and the day, like that. Now we're going to merge the data into one huge data table. So in this case, we're just going to merge for every data table into one huge data table for us to make us easier to be used for our predictions. Then for our pre-processing here, we can see that we are going to we aggregated the data using quantity and the date. So we can see like in this one here, and I just did some plotting here to give a visualizations about the data itself. And then we're going to take a look at the trend and seasonality. So for this part, I actually find that the trend, even though it fluctuates really pretty often in this case, but there's actually a really slight downwards trajectory if we just follow each points from January 2022 to December 2022. It slightly indicates that there's a downward trend. And for our seasonality, it is pretty clear that the seasonality of this data is basically more of a not looking really good in terms of the sales because it shows decrease. So it reaches the point -2, which basically the trend is that it keeps going downwards. It keeps declining like so. And we can take a look at the residuals of this data. But otherwise, that's it for the trend and the seasonality. Then we're going to conduct a stationarity data checking. So in this case, we used augmented Dickey Fuller test to find the p-value of our data. So we created two hypotheses. The first one being H0, where the data will be non-stationary, and H1 or hypothesis 1, the data is stationary. So the condition is that if our p-value of this test is lower than 0.05, then we are going to reject the the zero hypothesis, or H0. So since our p-value for this test returns 0 and it's lower than 0.05, so we are going to reject the H0 and we are going to accept the H1 instead. So in this case, the result concludes that the data is stationary, and we are going to take D equals 0. So I'm going to explain the D value later for the ARIMA modeling. Next, we are going to split the data into data training and testing. So I'm using 80% of our data for the data training and the rest 20% for the testing. Just like in this plot right here. So the left side, the blue one, will be our training model, and the right side, the orange color, will be our testing model. Then we are now going to find the optimum parameter of ARIMA. So ARIMA actually stands for Autoregressive Integrated Moving Average Model. So in this case, it's divided into three parts: AR, IM, and A. So AR, basically autoregressive. The simplest explanation should be we're going to find a model and we're going to put it in the p-value, and the integrated part, which will be put in the d value, and the q, which for moving average model, will be inputted for the q value. So that's the simplest explanations, I guess. And just now we discovered that the d is equal 0. So this means that we don't have to conduct a differencing for our data. So if the p-value in our previous test for our augmented Dickey Fuller test returns more than 0.05 and the data is non-stationary, means that we have to conduct a differencing to our data. So in this case, the d will become 1. And if the data still do not return stationary, we're also going to conduct a second differencing, and the d will be 2, just like that. So because the data is already stationary, we're going to use d equals 0. And for our first model, I did use AutoArima model. So in this case, I use the AutoArima model to find the value of P, D, and Q for our data train. However, it returns 0 to all of them, with the AIC equals 2485.95, around that number. And this might happen because our data is stationary. That's one thing. So the D is 0, and this would impact the P and the Q value of our data. And another reason would probably because our data actually probably don't suit the ARIMA model in general. So that's why the data itself returns 0.0.0. And for our second model, I'm using ACF and PACF plot. So ACF and PACF both stands for autocorrelation plot and partial autocorrelations plot. So for partial autocorrelations, the value will represent our P value, and for autocorrelations, the value itself is going to represent our Q value. However, as what I said before, the data itself is pretty unique in general, in terms that the partial autocorrelations and the autocorrelations both returns pretty similar, almost have no distinction whatsoever in terms of their lags. So in this case, from 0 to 30, it can be seen that the 28th lags here is which is the lag that is out of the significant limit. So that's why I'm using 28 for my ACF and PACF plotting. And hence the result for our P and Q for both models would be 28, with the AIC returns to 2531.353 for our value. And just to give another comparison for our second model, I'm using my third model, which is a pandas autocorrelation plot. So there's this autocorrelation function in the pandas that I use to find for our third model's P's and Q value. In this case, one of the points that somewhat exceeded the significant limit, or in this case the 95 confidence band, is 44 in this one here. So with the trial and error method, as well as using the intuitions, I use this number and plot this into my ARIMA model. So it returns 44.0.44, with the AIC value is 2559.662. And after having the three of the models ready, so I'm using ARIMA modeling to find the we're going to test. So I did the testing with these three models. And for our first model, we can see depicted by the red color is actually it cannot give us any prediction whatsoever. It returns flat line since our P, the ND, and Q value returns 0. And the interesting one is actually the second model and the third model actually. We're going to talk about that later, but we can see here for our MAE, MSE, and RMSE value, as well as the MAPE value for each models. The lowest being the first model, but we can obviously understand why the model itself returns really low, because the P, D, and Q both return 0. But the second model and the third model, if we can compare both of the models, the second model actually has somewhat similar MSE value to the first model. So here we can see that the second model actually depicts 255.10 MSE. So it's only like 8.5 actually, 8.5 to 9 points apart from the first model using AutoArima. And the MAPE, or the mean absolute percentage error, it returns 31.87. So it's actually less than our first model using AutoArima. So that's what is the second model gives us. And for our third model, since we used quite large number for our P and our Q, it returns quite a significant value as well, with the MSE returns 290.53, and for our MAPE it returns 33.02%, which is pretty high at this point if we compare to the other previous two models. And for the prediction itself, we can take a look at this graphics. The actual test value itself is being depicted by the color orange. And by neglecting the color red for our first model of predictions, we can actually see that the green model for our model 2 and the purple color for our third model actually shows somewhat similar trajectory in this case. So we can take a look, for example, during the second week of November, both models return upward trends in this case, the same with the actual predictions, as well as the last week of November. 3 of the lines actually shows that there will be a slight decrease or slight fall in this case right here. So I know the model itself cannot depict a really somewhat accurate model, but this is what I came up or get close at this point. And for our future forecasts, so in this case I did some forecasting for the year 2023, since the testing data only reach until 2022. And in this case, 2023, it returns pretty similar value actually for both second model and third model. For the details here, we can take a look at this part. So the second week of January actually returns an upward trend, and for the early February or the late January, in this case they both shows first it declines and then it falls back and goes upwards. So it's pretty consistent, giving our trend and seasonality value from our first interpretations. And the same trend happens again at the end of the February and the early of March. So this trend actually keeps on repeating by itself. And my advice for the inventory team, because the data itself returns with this kind of trend or seasonality, I would suggest you make sure that there will be enough stocks for each month, especially in the early, for the first week or the second week of the month. Make sure that you always have enough stocks for your items, regardless what kind of items that is. And other than that, be prepared to have low sales at the end of the month. And now let's move on to our customer segmentations using our k-means clustering. So in this case, we are going to take a look at our data. So we first conducted a data pre-processing. So for this case, we are going to take a look at the three criteria for our clusterings. The first one is being the transaction ID, how much transaction does a person make, and then the quantity, which is the amount of the item. Like for example, if she buys only like one toothbrush, or maybe like if she or he buys a box of coffee, something like that. And then the last one, which is going to take a look at the total amount for each item. For example, does she buy 5 boxes or 3 bottles, something like that, right? And then we're going to conduct a data scaling, and on the right side we can see the plot for our customers. Now for our k value, since we are using a k-means clustering, I use 2 methods for this k-value analysis. The first one using elbow method. So by analyzing the inertia in this case on the right side graph, I concluded that the number 3 is actually our optimum value for our elbow method. Hence, I use 3 as elbow method's results for our k value. The second one, I'm using a silhouette score. So our silhouette score basically returns 3. We can see in the graph on the right hand side that both, actually not both, 3 of the clusters shows a pretty average in terms of the width and in terms of the amount of the silhouettes, both red, green, and blue. And all 3 of them actually exceeded the average amount, so that's a pretty good thing as well. And if we take a look at the 4th and the 5th one, we can see that the red and the pink is slightly, the amount is slightly higher than the other silhouettes. So I decided to neglect that, and I also used 3 for our silhouette scores for our k value. So since elbow method and silhouette method results returns 3, I decided to use 3 for our number of clusters for this customer segmentations. So this is the result after using the clustering. So we can see that there are 3 clusters represented by the color green or cyan, yellow, and purple. And this is the 3D representations for the customer segmentations. And this is the segmentation results. So we can see that there are 3 clusters, and the result for their transaction, quantity, and total amount. So we can see that here for the cluster 0, the cluster 0 is actually pretty low. It's actually only consume like a third of the pie chart on the right side. So it's like a third of them. And I call this a low activity customer because it has a low transaction and a low quantity, as well as a really small total amount. So I would assume this cluster would have infrequent or not as frequent transactions and make usually a relatively small purchases. And for the first cluster, It's the biggest out of all three, with the numbers around like 45.5%. Almost half of our customers belongs to the average activity or mid-level customer. So in this case, they have a middle transactions quantity and a middle total amount for each items. And I would say that this represents the middle ground for our both transaction frequency and purchase amount. And the last is our second cluster, which is on high activity or high value customers, where they would buy or they would purchase a large transactions and a large total amount for our products. And I would say that this is our most valuable customers who make frequent purchases and spend a significant amount with our business. And lastly, I think is that this cluster is our loyal customers who sees value in our products. Now for the recommendations for our marketing team for each clusters. So the first one for our cluster 0 or low activity customer, I would suggest to focus on increasing their transaction frequency and order size through social promotions and incentives. Maybe gives them a points or rewards to encourage them to spend more, and particularly for the items that they have purchased before. And we can also utilize social media such as emails to recommend the products that complements the items that they have purchased before. For example, if someone just bought a toothbrush, we can try to give them promotions about toothpaste, something like that. And we can also promote our own sale items for the month to motivate them to shop more and increase their transactions and total amount values. And for our first cluster, which is our mid-level buyer, I would suggest to maintain and slightly boost their activity levels through loyalty programs and personalized recommendations. So this way, we hope that these clusters can maintain their frequently purchased routine to continue and to basically encourage them to keep purchase our products regularly. And I would also suggest to offer an exclusive discounts and promotions for this cluster to create a further engagement, so we can take these clusters, maybe some of the customers, and put them into the second clusters, hopefully in the future, which is the second cluster, which is basically the high value customers, which is the most valuable customers or the most valuable clusters out of all three. So in this case, our high value customers, we would try to focus to retain and nurture these customers by providing excellent customer service, exclusive offers, and premium loyalty program to keep them engaged and loyal. Since they are our most valuable customers, in my opinion, we can try to give them the best customer service, promotions, recommendations out there for these clusters. And one other thing is that we can try to give them an early access promotions to our new selling product, or limited edition products through the personalized recommendations based on their previous purchases. And that would be it for my presentations for my data scientist's internship program for Kalbe. Thank you very much for listening. I apologize if there are any mistakes in my interpretations or in my language. And other than that, have a very good day, and I'll see you next time. Thank you very much.